we have done with how many? 5, and we are just left with the last one. Okay, so we have used collision frequency, which is per unit time, collision rate, which is per unit volume, rate quality control, which is comparing the rate with the normal value, equivalent property damage, where we consider the weight of different types of injuries, and relative severity index, where we consider the cost of different types of crashes. Now we talk about sites with promise. Okay. First of all, in all the other methods, we focus on one aspect and neglect the others. Okay. So for example, in frequency, we do not consider volume. In volume, we don't consider frequency. In this one, or in all of them, we don't consider the weight of serious accidents. When we consider the weight of serious accidents, we do not consider frequency or something else. And in this one, we consider only the cost of different types of crashes. Okay, so we are not considering volume or time or anything. Okay, so in all these methods, we have considered one thing at a time. In sites with promise method, we try to combine different things into one method. Okay, so site with promise method has 5 conditions. So you are looking at the data from 5 different angles. Okay, so the first angle or the first condition is look at the planning of the area. The plan of the area from the authorities. Are they going to implement something which will affect some of the sites? For example, a new signal system. Okay, so new signal system will affect what? The signalized intersections. Okay, so that the condition becomes focus on signalized intersections. Clear? Okay, or another method can be that they are making some changes in the design of the roundabouts. So these changes will happen only on the roundabouts. So focus on roundabouts. Okay. So first of all, look at the planning of the authorities for that area and see this planning will affect which type of sites. And obviously we are not talking about general plan, like construction of a new highway or something. Plan which will affect the safety. Countermeasure means something which will improve safety or which will reduce crashes. Okay, so if somebody is doing some changes which is not directly related to safety, fine. Okay, that is something else. But which thing is planned which will affect safety of specific sites? Condition B is related to new sites. New sites means the sites on which we have recently done some major work. Maybe you have reconstructed the site, so we have constructed the site just now. So earlier there was no bridge, now there is a bridge. Or maybe you did some major reconstruction. So there was a bridge, but now you have changed everything. The number of lanes and the median, everything is changed. Okay, so some major work. So second condition says that compare the frequency of crashes on this site to other similar sites. Okay, so condition B is related to frequency. Okay, and it focuses on sites on which there has been some new construction. Okay, so the first condition related to planning, second condition related to frequency but focusing on new sites. Okay, and we calculate this ratio. What is this ratio? Frequency of crashes at your site, mean frequency of crashes at similar sites, standard deviation of frequency. Okay, clear? If your site has less crashes than normal, then this ratio will be what? If your site has less crashes than normal, than the mean, then this ratio will be minus. So minus means it's good. Plus means that you have to look how bad is it. So this is condition B. Condition C is are there any sites on which recently the crashes have increased? Okay, increased not like plus 1 or 2, like significantly increased. Okay, so it was 20, now it's 40. Okay, so if there are any sites like this, there's a condition for that. Are there any low volume sites that could be missing because of the exposure? Now, for low volume sites, then I have to consider the rate, because I talk about volume, right? So how can I talk about volume without considering the rate of crash? So I will now, for condition D, I will calculate the rate per unit volume. Okay, rate per unit volume. So condition D is about rate of crashes. Okay, and then we have condition E, which is again for new sites, newly constructed sites, but now we are not comparing the frequency. Now we are comparing the rate. Okay, clear? Okay, so there are how many conditions? A, B, C, D, and E. 5 conditions. Okay, one of them is related to planning. Is the government making any changes related to safety which will affect some of the sites? 2 of them are related to new sites. Okay, and 2 of them are general. From these 2, condition D related to rate, and condition B, condition C, which is related to frequency. Clear? Okay, so you will apply all these 5 conditions together now. Okay, so in the earlier methods, 1 condition at a time, one thing at a time. Now we are looking at it from 5 different angles. Okay, so they have this department, don't ask me the name, and they have a budget of $1 million. Okay, and they are focusing on signalized intersections. Hurry up, hurry up, hurry up. Okay. They are focusing on signalized intersections. Okay, and they are not focusing on all types of crashes. They are focusing on crashes which are angle crashes, like this. Okay, left turning opposing crash. So you are taking the left turn and the opposite side. This type of crash, and rear end crashes. Okay, so 3 of them: angle, left turning opposite, and rear end. Okay, 3 types of crashes are focused. They are looking for any countermeasure. Okay, but they are more focusing on changing the lights of the signal. Okay, they already have in mind that our signals are very old. Now we are going to change them with these new lights. Okay, so this is like maybe at that time some sort of new technology in signal lights. Okay, so when you will put the new lights, it will increase what? Visibility, the sight distance. Okay, so now you have a countermeasure which will be useful here. Okay, so the data which they have, in that data there are 2 new sites. 2 sites which are just constructed, 2 intersections which are just constructed. Okay, and yeah. So now they are asking, so they have the data for 11 sites. I'll show you the data. This is the data. Okay, so they have 11 sites. Okay, 2 of them are new. Okay, site number 2 and site number 8. 9. Okay, these 2 are new, and the rest, the other 9 sites are old, and they have the data for 3 years. Okay. And for each year they are showing the collision separately. So it's not the total. We have the total obviously, but we have for each year as well. Okay, and the major and minor daily traffic, average daily traffic total. So this is total. Okay, so total on this intersection is 42,000 from both roads. Clear? Okay, and for our convenience we will not use it, but they have given the data for each type of collision as well. So from the total 45 were this type, for 21 were this type, and so on. Okay. Why it is given? Because the authorities are focusing on which ones? They are focusing on these three, right? Clear? Okay. So now we will apply the 5 conditions. Okay. The first condition was, are the authorities planning any change which will affect safety? Okay. What is that? What are they planning here? Changing the lights, okay, which will affect the visibility, okay, the signal sight distance. Okay, so when the sight distance will be improved, okay, then these types of collisions will get less, okay, because they are mainly happening because the drivers cannot see the signal properly. Okay, rear end collisions happens when somebody in front of you brakes suddenly. Okay, left turning or angle collision will happen when two people who are from different sides are reaching the intersection or entering the intersection at the same time. Okay, so these types of crashes will be reduced. So which side has more of these types? Okay, I think this table also has this. Yes. Okay, so looking at the planning of the government, they are trying to reduce those 3 types of crashes, these 3 types. Okay, so which sides have more of these types, which will be affected by the plan? Okay, so which of them are there? We have this one. 5. Okay, 5 and this one, right? 2. We have to select 2. So top 2 sides according to condition 1 is 1 and 5. Okay, you can expand your selection and you can make it 1, no problem. Okay, it's up to you. Okay, in this problem, according to the book, they are going for 2. Okay, if you have criteria like this, then 2 sides. Okay, so the top 2 sides are side number 1 and side number 5. Okay, then the next condition was, are there any new sites for which the frequency is higher than the other sites? Okay, other similar sites. So these are the similar sites, right? So the 2 new sites are which ones? Number 2 and number 9. Okay, the remaining 9 sites are old, but they are similar to them. All of them are signalized, right? All of them are same types of intersection. That's why we are comparing them together. I mentioned it yesterday as well. You cannot compare between sites which are different from each other. So since we are comparing between them, that means they are similar. Okay. The only difference is 2 of them are new. The rest are old. Okay. So the second condition will apply to these 2, site number 2 and site number 9. Okay. The frequency for site number 2 is 50, right? 50. There's only 1 year of data, right? So 50 per year. For this site, it is 24 per year. Clear? Okay. To compare it, okay, to compare it, we will be calculating this ratio. Fi, which is the frequency at my site, Fm, which is the mean, divided by the standard deviation. Okay, so how much is this for site number 2? Frequency is 50. Okay, the mean is 32.6 for all the sites, and the standard deviation is 5.6. So 50 minus this upon 5.6. How much?
3.11.
Okay, and for site number 9,